This lesson covers Chapter 9.2, Quadratic Inequalities in one variable. The solutions to quadratic inequalities in one variable are a range of numbers that satisfy the inequality. To write our solutions to quadratic inequalities in one variable, we use set notation, like we do with domain and range. Two ways to solving quadratic inequalities. When solving inequalities, we are looking for the values that make the inequality true. We can do this graphically or algebraically. Example, solve x squared minus 10x plus 16 is less than or equal to 0, i.e. what values of x will make the parabola less than or equal to 0. So when we say, because we have one variable on the left side, we just have x's, then when we say it's less than or equal to 0, we're saying that that's the y value. Y is less than or equal to 0. Let's see how we do this graphically. First of all, we want to graph our parabola using our graphing calculator. I'm going to go to my y equals. I'm going to clear what was there. I'm going to type in my new quadratic x squared minus 10x plus 16. It's in standard form, so the 16, the constant term, is our y-intercept, to at least know that. Hit enter, graph it. I'm going to change my window because it looks a little wonky. I'm just going to try zoom standard. And we see this here. To graph it, I'm going to find my vertex and I'm going to find my X intercepts. So second trace, vertex, it's a minimum in this case. I want to be left bound, left of the minimum point. So this dot somewhere along here would be left of this minimum point. I hit enter. Gonna move my little dot until it is somewhere right of that minimum point. And then it tells me that the min is at x equals 5, y equals -9. So we're just gonna do a quick sketch here. Let's say that it is here. And then we're going to find the x-intercepts. Second trace, number 2. I need to be left bound of the first one. So left of the first x-intercept would be up, above. Hit enter. Then I need to be right bound for the second one, so down below it. Hit enter. And then it is 2, 0. X equals 2. I want to find the second x-intercept, repeat that process, second trace 2, this time I want to be left bound of this x-intercept, so that would be below the x-intercept, hit enter, now I want to be to the right of that x-intercept, so in this case above it, hit enter, and it tells me that my intercept is at 8, about here. And then we can sketch our parabola. Doesn't have to look perfect, just a quick sketch. Now looking at our graph, this line, the x-axis, is when y is equal to 0. Above that line is when y is greater than 0, and below that line is when y is less than 0. Our inequality, x squared minus 10x plus 16, is less than or equal to 0. We want to know when the quadratic is less than or equal to 0? Well, that would be these two portions. It's equal to 0 at the x-axis, and it's less than 0 below that. So what are the x values that will provide us with the locations where the graph is at or below the x-axis, i.e. equal to or less than 0? Well, we can see that at 2 and at 8 it's equal to 0, and between those two it is less than 0. So the y values are less than 0 between x equals 2 and x equals 8. Also, the y values are equal to 0 when x equals 2 and x equals 8. So the y values are less than 0, the graph is below the x-axis, when x is between 2 and 8, and the y values are equal to 0 when x is at 2 and when x is at 8. Then we can say the y values are less than equal to 0 when x is equal to and between 2 and 8. So thinking about domain and range, how do we write this? We start with our lowest number. 2 is less than or equal to, because in this case it can, part of this, the inequality is that it's equal to 0, and it is equal to 0 at the x-intercepts, which are 2 and 8. So we would include the equal sign with that. So 2 is less than or equal to x is less than or equal to 8. That's our solution to this inequality in one variable. So notice how it's different from solutions to inequalities in two variables, where we drew a graph and shaded, and the solutions were any coordinate point in the shaded region. Now there's no shading. We're looking at a range of x values as our solutions. Let's solve this inequality algebraically. So for solving something algebraically, the expectation is that we're doing everything algebraically. So we would also be algebraically finding the x-intercepts. Let's factor this trinomial. You could factor or use quadratic formula, but use a algebraic method to find x-intercepts. Solve for x-intercepts. I'm going to factor. We have x squared minus 10x plus 16. I'm going to write it equal to 0. I need two numbers that multiply to 16 and add to negative 10. Multiply to equal 16. Add to equal 10. Negative 10, sorry. So they have to be the same sign because they multiply to a positive. Negative 8 times negative 2 would be positive 16. Negative 8 plus negative 2 would add to negative 10. Those are my numbers. Now we can write it in factored form. X minus 8, x minus 2 equals 0. Then we solve each binomial factor. X minus 8 equals 0. We have to add 8 to both sides to get x equals 8. And x minus 2 equals 0. Add 2 to both sides to get x equals 2. Those are our two x-intercepts. Now we are going to draw a number line. And we're going to plot those 2 points on our number line. 2, 8. Those are the x-intercepts. Then we're going to pick, we're going to do test points. We need to pick a point that's left of both x-intercepts. I'm going to go with 0. We need to pick a point. We also have the x-intercept. Then we need to pick a point between the x-intercepts. I'm going to go with 5. Then we have the next x-intercept. Then we need to pick a point that's to the right of that x-intercept. So I'm going to go with 10. We're going to test each point in the inequality, and we're going to see which ones come out as true. Our inequality is x squared minus 10x plus 16 is less than or equal to 0, starting with x equals 0. So starting on the left and testing each point moving to the right. We have 0 squared minus 10 times 0 plus 16 is less than or equal to 0. Going to our calculator, go back to this. We don't need to really calculate this. Those are 0, so 16 is less than or equal to 0. Is that true? No, that is false. Next point is x equals 2. Sub it into our inequality. 2 squared minus 10 times 2 plus 16 is less than or equal to 0. Because it's an x-intercept, the y value is 0. So when we calculate this, it better come out as 0. If it doesn't, we did something wrong. 2 squared minus 10 times 2 plus 16 comes out as 0. 0 is less than or equal to 0. Is that true? Yes, because it has 0 is equal to 0. Next point is x equals 5. 5 squared minus 10 times 5 plus 16 is less than or equal to 0. Calculate 5 squared minus 10 times 5 plus 16 gives us negative 9. Negative 9 is less than or equal to 0. That is a true statement. Next value is x equals 8. Also an x-intercept, so it better come out to be 0. 8 squared minus 10 times 8 plus 16 is less than or equal to 0. Sub it in. 8 squared minus 10 times 8 plus 16 gives us 0 is less than or equal to 0. It's a true statement. Last point is x equals 10. Sub it in. 10 squared minus 10 times 10 plus 16 less than or equal to 0. Calculate 10 squared minus 10 times 10 plus 16 gives us 16 is less than or equal to 0. Is that true? No, that is not true. So these points here are telling us where our solution is. I can use my number line again to draw a picture of the solution, so I know that the x-intercepts are included. So I put a solid filled in dot at the x-intercepts, and then I know that the numbers between the x-intercepts are included. So I draw a line between the two x-intercepts to show that that is my solution region. And then to write that in set notation as we did before, we start with our smallest number, which was 2, which is less than or equal to x, which is less than or equal to 8. That is solving algebraically. We algebraically solved for our x-intercepts. Then we drew our number line, picked our 5 numbers, did our test points, saw which ones are true, and then wrote our solution based on that. Next example, solve negative x squared plus 3x plus 10 is less than or equal to 0. We know that it opens down because it's got a negative a value, and we know that our y-intercept is at positive 10. Let's use our graphing calculators to figure out some more points to help us graph. Going back to my y equals, clearing what's there, negative x squared plus 3x plus 10, graph. I'm going to move my window just up a little bit. I just want to see a little bit higher so I can see the vertex. So that would be my y maximum. Change that to maybe 15. It didn't look like it needed to go much higher. And then graph. There we go. Okay. I need to find my x-intercepts. I need to know those so that I can use them for my test points. So second trace, number 2, 0. Enter. Oh, I need to be left bound. Put my dot left of the smallest x-intercept, which in this case would be below the x-axis. Hit enter. I need to move right bound. In this case, that would be above the x-axis. Hit enter, and it tells me it's at -2, 0. So we'll say that that is about there. And then do the same thing for my next one, second trace, option number 2. Left bound of my larger x-intercept would be above the x-axis. Hit enter, right bound would be below. Hit enter, and it is 5, 0. So 1, 2, 3, 4, 5, about there. And then we know that our y-intercept is at 10. Let's find our maximum point, number 4. We need to be left bound of the maximum. So here is left bound, enter. We need to be right bound. There's right bound, enter. And it tells me it's at 1.495 and 12.2. So we'll say that's 1.5, about 1.5 and 12. So we say that that's about here. And then we can draw our parabola. There we go. Okay, so looking at the graph, we have the x-axis is where y is equal to 0. Above that point, y is greater than 0, and below that line, y is less than 0. Our inequality is asking when the quadratic, negative x squared plus 3x plus 10 is less than 0. So looking at our graph, when it's less than 0, that would be this section here, just including the bottom, not including the x-axis, and not including above the x-axis. Okay? So when do we see it's less than 0? We see at this arm and at this arm. So they're going away from each other. These two pieces are not connected together. They are separate. So we'd have to write them in two different statements. So this is going to be true for when x is greater than 5, not greater than or equal to, because if it was equal to, it would have to be equal to 0 in our inequality. And when x is less than -2. Putting those together, we usually write the smaller number first. So x less than -2 and x greater than 5. I have to write them in two separate statements because the pieces are not connected. Let's solve this one algebraically now. We need to algebraically solve for our x-intercepts to start with. We can factor or use the quadratic formula. I'm going to factor. So starting with my inequality negative x squared plus 3x plus 10, I'm going to write it equal to 0 for factoring. I need to take out the common factor, which in this case is negative 1. We want the x squared term to be positive, so we're factoring out negative 1. We get x squared minus 3x minus 10 equals 0. Now we just want to factor this trinomial, x squared minus 3x minus 10. We need two numbers that are going to multiply to negative 10, and they need to add to negative 3. So they have to be opposite sides to multiply to a negative, and one of them has to be, the negative one has to be a larger number than the positive. So negative 5 and 2, negative 5 and 2. We're going to multiply negative 10, add to negative 3. Then our factored form, negative in front, that's a common factor, or negative 1, whatever you want to write. X minus 5, x plus 2 equals to 0. Solve each binomial factor. So we have x minus 5 equals 0. We want to add 5 to both sides. We get x equals 5. X plus 2 equals 0. We want to subtract 2 from both sides, and we get x equals negative 2, which are the same x-intercepts we had when we did it graphically. Next, we want to do test points. Draw our number line. We need to start by plotting the x-intercepts, negative 2 and 5. Then we need to pick a point that's left of the smallest x-intercept. I'm going to go with negative 3. Pick a point that's in between the two x-intercepts. I'm going to go with 0. Pick a point that is to the right of the largest x-intercept. I'm going to go with 6. Now we need to sub these points into the inequality and see when we get a true statement. Starting at the left and working our way to the right. X equals negative 3. Plug it into our inequality. We have a negative x squared. So negative in front, bracket, negative 3, close bracket, squared. Then plus 3 times negative 3 plus 10 is less than 0. Calculate negative bracket, negative 3, close bracket, squared, plus 3 times negative 3 plus 10, and we get negative 8 is less than 0. Is that a true statement? Yes, negative 8 is smaller than 0. Next value is x equals negative 2, which is the x-intercept. So when we plug it in, we better get 0. Negative bracket negative 2 squared plus 3 times negative 2 plus 10 is less than 0. Negative bracket negative 2 close bracket squared plus 3 times negative 2 plus 10 gives us 0. 0 is less than 0. Is that true? No, 0 is not less than 0. Now we're going to plug in x equals to 0. Negative 0 squared plus 3 times 0 plus 10 is less than 0. Well, that's 0, that's 0, so we have 10 is less than 0. Is that true? No, 10 is greater than 0. Next value is the second x-intercept. X equals 5. Negative bracket 5 squared plus 3 times 5 plus 10 less than 0. Negative bracket 5 close bracket squared plus 3 times 5 plus 10, and we get 0 because it's the x-intercept. 0 is less than 0. Is that true? No. Last point, x equals 6. Negative bracket 6 squared plus 3 times 6 plus 10 is less than 0. Plug it in, bracket negative, then bracket 6, close bracket, squared plus 3 times 6 plus 10, negative 8. Negative 8 is less than 0. Yes, that is a true statement. So our positive solutions happen here and here at x equals negative 3 and x equals 6. Those are the values that are to the left of the smallest x-intercept and to the right of the biggest x-intercept. They do not, the x-intercepts themselves do not provide true statements, but that is where the solutions start. So to draw it, we draw an open circle at the x-intercepts, and then we draw an arrow pointing left of the smallest x-intercept and an arrow pointing right of the largest x-intercept. So all of our solutions are smaller than negative 2 and greater than 6. So any number smaller than negative 2 is a solution to the inequality. Also, any number greater than 5 is a solution to the inequality. How do we write that? Just like we did before, x is less than negative 2 and x is greater than 5. Example, solve x squared minus 4x is less than 10. Round values to the nearest 10th. First thing we want to do is move the 10 over so that it's all less than 0. I'm going to subtract 10 from both sides. We get x squared minus 4x minus 10 is less than 0. And then we continue as we did above. So let's graph this to find our x-intercepts. Y equals, clear what I had, enter our quadratic x squared minus 4x minus 10, enter graph. Okay, I want to make my window a little bit smaller. I want to see lower down so I can see my minimum. So I'm going to change my y minimum to negative 15, I'll try. And then I don't need to see, oops. Window. Clear that. Negative 15. And I don't need to see as high as I did last time, so I'll change that back to positive 10, and I will graph that. Let's find the x-intercept, second trace, number 2, left bound, left of the left x-intercept would be above, hit enter, right bound would be below for this x-intercept, hit enter, and it tells me it's at negative 1.742 for the y value, so we'll just say that that is here. And negative 1.7 we'll call it. And then second one, second trace, number 2, left of the bigger x-intercept would be below, hit enter, right of the bigger x-intercept would be above, hit enter, and it's 5.74, so we'll call that here 5.7 we'll say. Let's find the vertex. Second trace, it's a minimum, number 3, left bound of that vertex, hit enter, right bound, hit enter, and it's at about 2 and negative 14. So we'll say that's like there and there. And then we can draw our parabola. Looking at our parabola, we have at the x-axis, that is y equals to 0. Below that is y is less than 0, and above that is y is greater than 0. Our inequality is asking for when the parabola is less than 0. Just less than, not less than equal to. So that is just this section. Okay, that's going to happen between the two x-intercepts we see. That part is all connected. So this stuff down here, not including the x-intercepts, which means it's going to be the values between the x-intercepts. So we can write that as negative 1.7 less than x, which is less than 5.7. Does not include the x-intercepts because it's not equal to 0. It's just bigger than the smallest x-intercept and smaller than the biggest x-intercept. Let's solve this one algebraically now. Since we already know that our x-intercepts are going to be not integers, not whole numbers, we're not going to factor. So we're going to use the quadratic formula to find our x-intercepts. Our a value is 1, our b value is negative 4, and our c value is negative 10. The quadratic formula is x equals negative b, so negative 4 plus minus the square root of b squared, negative 4 in brackets, and then squared, minus 4 times a, which is 1, times c, which is negative 10, all divided by 2a, which is 1. We're going to calculate. We're rounding to the nearest tenth, so we don't need to simplify this at all. We can just plug it right into our calculator and get our two numbers, one when we do a plus and one when we do a minus. Bracket, because I want to bracket everything around the whole top. So bracket for the top, negative, bracket, negative 4, plus, we need a plus first, square root, second function x squared to get square root, another bracket, open bracket for bracketing everything that's inside the square root, another bracket for negative 4, and then close bracket, and then squared, minus 4 times 1 times negative 10, close the bracket, that's everything inside the square root. Then I'm going to go over and close the bracket for what's on the top of the fraction. Then divide, open a bracket, 2 times 1, close the bracket to group everything that's on the bottom of the fraction, and hit enter. We get 5.7416, blah, blah, blah. Same thing, but do a minus. So I'm going to go back up, highlight my equation, hit enter. Then I can go back and edit, just change that plus to a minus, and we get negative 1.7416, dot, dot, dot. Now we do our test points. Start by drawing our number line, plotting the x-intercepts, negative 1.7416, dot, 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 and 5.7416, dot, dot, dot. Pick a point that's to the left of the smallest x-intercept. I'm going to go with negative 5. Pick a point that's between the two x-intercepts. I'm going to go with 0. Pick a point that is larger than the largest x-intercept. I'm going to go with 10. These two are x-intercepts. Start with the point on the left and test each of the 5 points in the inequality. X equals negative 5. Just going to zoom in on this. Our inequality is x squared minus 4x minus 10 is less than 0. So negative 5 in brackets squared minus 4 times negative 5 minus 10 is less than 0. Plug it into our calculator, bracket, negative 5, close bracket, squared, minus 4 times negative 5 minus 10 equals 35. 35 is less than 0, false. Next point, x equals negative 1.7416, dot, dot, dot. This is an X intercept, so we expect the answer to be 0, but because it's a dot, dot, dot number, it continues on and on, we're really using a shortened version of it or a rounded version of it, which means that we're not going to get exactly 0. So we should get a number really close to 0, and we'll just call that 0. Let's try it. Negative 1.7416 squared minus 4 times negative 1.7416 minus 10 is less than 0. Plug it in. Negative 1.7416 close bracket squared minus 4 times negative 1.7416 minus 10 is negative 4.294 e to the negative 4. That means move your decimal 4 times to the left, so it'd be negative 0.0004. So 0 is less than 0. Is that true? No, that's not true. Next point, x equals to 0. Plug it in. 0 squared minus 4 times 0 minus 10 is less than 0. Those are 0. We get negative 10 is less than 0. That's true. Next point, x equals 5.7416. Again, this is our x-intercept. We expect it to be 0, but it's also not the full value of the x-intercept, so we know it's going to be really close to 0, and we'll just call it 0. Plug it in. 5.7416 squared minus 4 times 5.71416 minus 10. 5.7416 squared minus 4 times 5.7416 minus 10. Again, same answer, negative 4.2944 e negative 4, so times 10 to the power of negative 4, which is 0. 0 is less than 0. Nope, it is not. Last point, 10, x equals 10. 10 squared minus 4 times 10 minus 10 is less than 0. 10 squared minus 4 times 10 minus 10 is 50. 50 is less than 0. Nope, it is not. So our solution is between the two x-intercepts, but not including the two x-intercepts. So if I draw a picture, we'd have open circles at the two x-intercepts, not filled in because it's not included, and then we would attach those two open circles with a line to show that the solution is anything between the two x-intercepts, but not including the two x-intercepts. And then to write that in set notation, we would have rounded to the nearest tenth, negative 1.7 is less than x, not equals to, because the circle is not filled in, and the inequality is not true at the x-intercepts, just less than, and then x is less than 5.7. Solve x squared is less than negative 3. First step, we want it to be less than 0, not less than a number, so we want to move that over by adding 3 to both sides. Then we get x squared minus, or plus 3 is less than 0. Now we want to graph this quadratic. go to our y equals, clear what was there, enter x squared plus 3, graph that, and we get this. Let's find our minimum. Number 3, left bound, enter, right bound, enter, and it's at basically 0 and 3 is what it really should be. 1, 2, 3, put our dot there, and it opens up. So we can't really graph the x-intercepts because there are no x-intercepts. So what happens if there are no x-intercepts in this case? Y is greater than 0, y is equal to 0, and y is less than 0. Our inequality is asking when is y less than 0, which would be down here. How much of the graph is down there? None of it. So how many solutions do we have? No solutions, okay? So the graph only has positive y values. Therefore, no solutions to x squared plus 3 is less than 0, which means y is less than 0. There are no solutions that give us values on the graph where y is less than 0, so there are just no solutions to this inequality. Last example, suppose a baseball is thrown from a height of 1.5 meters. The inequality negative 4.9 t squared plus 17t plus 1.5 greater than 0 models the time t in seconds which the baseball is in flight. During what time interval is the baseball in flight? Let's start by graphing this. Clear that. Negative 4.9 t squared, call our t x, plus 17t plus 1.5, graph. I'm going to increase my window to see vertically up. This is real life, so I don't really need to see much of the negatives because time and height, those are only going to be positives, so I can really get rid of the stuff that's below the x-axis. I'm going to go to window. I'm going to change my x min to like -5. I'm going to leave my x max because it was big enough. I'm going to change my y min to -5, and I'm going to change my y max. I want to go higher, so I'm going to, I don't think I needed to go much higher. I'm going to change it to 15. Okay, I need to go a little higher. So window, go down, y max, I'm going to change that to 20. Let's find the x-intercepts. Second trace, number 2. Put my dot left of the first x-intercept, hit enter, put it right of the first x-intercept, hit enter, and it shows that it's at negative 0.086. Do the second one, second trace, number 2, left of the first, or the bigger x-intercept, hit enter, right of the bigger x-intercept, hit enter, 3.5-ish. So about here. And then we know that it crosses the y-axis at 1.5. So let's say that that's about here. And then our vertex, second trace, it's a maximum, number 4, left of the max point, enter, right of the max point, enter. It's at 1.73 in about 16, so almost at 2, and we'll just go up here somewhere. And then we can draw our graph. Now this is a ball that's being thrown, so when we get to the point before time, this is time, in seconds. This is height in meters. We really only care about from the y-intercept. That would be where the ball is thrown. Time is 0, and then after that. So it goes up and then it comes down. And what we want to know is during what time interval is the baseball in flight. So obviously it starts at time 0. Basically it's saying, when does it land? Well, according to our, I forget what the number was now, second trace, number 2, our second x-intercept was 3.55. So 3.555 seconds. So our interval would be 3.6 seconds. Let's do that algebraically. We would not want to factor this. So using the quadratic formula, solve for x-intercepts using quadratic formula. X equals, our a value is -4.9, our b value is 17, and our c value is 1.5. X is negative b, so negative 17 plus or minus the square root of b squared, 17 squared, minus 4 times a, which is -4.9, times c, which is 1.5. All of that over 2a, which is 2 times -4.9. Go back to our calculator. Clear that. First I want to put brackets, so I can put brackets around all of the top. So bracket -17 plus square root, bracket again, open bracket, 17 squared minus 4 times -4.9 times 1.5, close bracket and close bracket again, then divide by bracket 2 times -4.9, close bracket, enter. We get, when we do the plus, -0.0860, blah, blah, blah. And then when we do the minus, I'm going to go back up, hit enter, go over, change the plus to a minus, hit enter, and 3.5554 ... we're talking about time. These x-intercepts represent time. We cannot have a negative time. Can't have negative time. So this would have to be our x-intercept. 3 point, doesn't say where to round to, so we'll say 3.6 seconds. What's the time interval that the baseball is in flight? Well, at time 0, the baseball is not in flight, but as soon as we move past time 0, it's in flight. So 0 is less than t, which is less than, as soon as we hit 3.5554 or 3.6 seconds, that's when the ball lands, so it's no longer in flight, but before that, it is in flight. So that's why we're going to use the less than signs instead of the less than equals to. So 0 is less than t is less than 3.6, and that's seconds. 0 seconds is less than t is less than 3.6 seconds. That is the end of lesson 3 for Chapter 9, solving quadratic inequalities in one variable. And that is also the end of the Chapter 9 lessons.